Hello, my DevNation friends from everywhere in the world. Welcome to another Tech Talk. And today we have the great Alex Soto Bueno, we work together at the Global Developer Experience team at Red Hat, and he's going to talk a bit about security and Istio. So two great subjects. So let's greet Alex. So hello, Alex.
Hello.
Yeah, how are you doing?
Good. Just prepared for this great session about Istio and security, which you will see that Istio helps you to make your microservices architecture more secure.
Yeah. Awesome. And how's the weather in beautiful Barcelona?
It's Barcelona. It's sunny.
So awesome. So today, live from Cary, North Carolina and Barcelona, Spain, welcome to DevNation. Alex, the stage is yours.
Thank you. So I think that I'm sharing my screen. I think that everyone can see my screen. So we can start. Okay, let's go. So, as usually, um, all of our stuff is open source. So it's the tutorial, the slides, everything. It's ready for you. So if you go to dn.dev/istio tutorial, you will see that the Istio tutorial that we developed for you, and you will be able to learn Istio and also reproduce everything that I'm going to show you today. You can do it at your home just using a Minikube or using OpenShift. And if you're interested in the slides, of course, the end.dev/istiomaster, and you'll see like 100 and something slides about Istio. My name is Alex Soto. As Ed said, my Twitter handle is AlexSotoB, and my email is asotoweb@redhat.com. If you got any question, you can wait until the end of the session using the chat and so on. But if you are rewatching this session or the question comes later, you can ask me either in Twitter or in email. And I am also the co-author of Testing Java Microservices and the Quarkus Cookbook. And remember that it's April. And since it's April, it means that there is Red Hat Summit. And if you want to be updated with the latest things that we thinking at Red Hat that it's going to be a super hit this 2021 and 2022, then register to the Red Hat Summit that I left here the link. So let's just start a bit of how we developed in the past. We developed like a monolith application with just a single database, a single database or a big or several databases, but all these databases being accessed by a single point, a single monolith application, and everything was together. Right? It was just a big application with several modules inside. But nowadays we are into the microservices architecture or services architecture, right? Where we break down all these monolith applications into several services, all of them interconnected with the network, with several databases, several entry points. And one of the key points of this services architecture is that instead of deploying to production once every 6 months, as we did in the past, we are starting deploying several times per week. This implies that we need a way to deploy really easily. And this is exactly what Kubernetes and OpenShift is doing. At the end, OpenShift is just a Kubernetes implementation, and Kubernetes and OpenShift really helps you on deploying several times per week. Because at the very end, microservices or service architecture is nothing more than distributed computing. It's exactly the same thing that we did in the past. That I'm quite old, so I just used Corva and RMI technologies like that. I know that now microservices are super cool, right? But it's at the end, it's the same concept. We've got a service that sends requests to another service, and then this other service processes the data and returns the response to the caller, right? And then this can be scaled up to more and more and more services. And this has an implication that now, since all the services are interconnected using the network, we at Red Hat said that our services apart from the business logic, requires that you implement one thing that we call microservices. And these microservices, I like to call them like cross-cutting concerns, in the sense that it's something that you need to implement atop of your service to make your microservices architecture running correctly. And some of them, it's like defining an API, find a way to discover services, invoke a way to discover, invoke services, the concept of elasticity that you can scale up and scale down your service, resiliency. Now there is the network between calls, and the network is not always reliable, and it means that we need to make our services resilient. A pipeline, each of the service can be deployed independently, so each of the service requires its own pipeline. Authentication, how we authenticate internal calls between services. And then logging, monitoring, and tracing is something that it's a bit more complicated when you are into the microservices architecture. So basically, in the past, we did something like that, right? We implemented our service, and inside, we developed all these microservices. For example, if you are using Netflix OS or Istio or Resiliency4j, Jigger, all these kind of APIs, at the end, you're putting all this stuff inside the business logic. But if you start using OpenShift or Kubernetes and OpenShift, if you're using Kubernetes, then you fix three of these microservices. First one, discovery, with the concept of Kubernetes service, right? That gives you a virtual IP and a virtual static IP and a static DNS name to access the services. So we find a way to discover them. Invocation, Kubernetes prepares all the network for you, and elasticity. You know that you can do skip kernel, scale up, scale down, replica, set the replica names, and then it's a scale up and down automatically. So this is covered by Kubernetes. If you're using OpenShift, we also have the pipeline covered, either by Jenkins or by Tecton, and logging and monitoring. But what's happening with the rest of the concerns, then this is where Istio comes. With Istio, we are covering more of these things. For example, we're covering resiliency, we're covering authentication, tracing, and of course, there is some kind of overlapping between discovery and monitoring. But Istio is the solution for your microservices. So before Istio, we had something like that. With Istio, thanks of the sidecar container, and remember that the sidecar container is just a container that is inside the same pod of the main container, and it gives you some features that are not in the main container. For example, in this case, when we are starting using Istio, we've got this. We've got a pod with two containers, a container with service A, the business logic, but the important thing is that now service A has no microservices implemented. All these microservices are inside this sidecar container. And then the pod contains two containers, my business logic and my microservices. And what's really happening with Istio is that this sidecar container intersects all the network traffic, which means that we can manipulate the traffic in this sidecar container. We can reroute in whatever we want. We can encrypt the traffic. We can protect the traffic. We can make traffic valid or not, depending on some rules. Okay, and this is exactly what happens with Istio. But this is not an Istio talk per se, it's a security plus Istio. So I want to show you how Istio can help you from the point of view of security. And I will going to see these 5 points. Again, remember that all of them are explained in our tutorial, and you can reproduce at your own computer. And it's egress blocking, MTLS, access control, JSON web tokens, JOT authentication, and airbag authorization. So one of the things that we need to keep in mind all the time in a microservices architecture is that most of the communications are inbound and internal. Usually, what we need to protect is the internal communication. This is something that we think that, okay, it's an internal communication, it doesn't matter, but it's not true. We need to protect the outbound communications, the external communications, but also the inbound communications and the internal ones. So what is egress blocking? This is one of the things that we've got with Istio, is that when you, as a developer, wants to access to an external, a third-party service, right? For example, suppose that I got my service and I want to access Twitter, okay, the Twitter API, then this is an external access. And by default, Istio allows you this kind of traffic. But notice that it's not secure at all, this approach, because some attacker could get access to one of these services and start sending data from the mesh outside to his black server. Okay, so it's something that you would like to protect. And this is exactly what you're getting with egress blocking access. It's blocking external or outbound communications and only allow the ones you have registered. The second thing is encryption. Usually we tend to not encrypt traffic between internal services. We are not using HTTPS. The reason is that HTTPS is hard, right? And as a developers, we do not want to deal with certificates authority, certificates that has expired, keys, private keys, public keys, all this kind of stuff. It's quite, cumbersome and hard to understand. So we tend to not encrypt the internal communications. And this is something that we might not do. The reason is that this is my application, but what's happened if an attacker is able to do an eavesdropper pod and just start sniffing all the traffic between customer and preference. Notice that these are internal pods. They start sniffing everything and would be able to see the content. Okay, for this reason, it's important to protect internal traffic. Another thing that Istio improved in the security is the access control. It's important to define which services can access to what services, right? So for example, I can say that customer can access to preference and preference can access to recommendation. That's fine, but customer cannot access recommendation or recommendation cannot access preference. So I need to provide an access control to the calls. So any forbidden call, any call that I might not expect to happen is protected. Of course, we can protect as well the outbound traffic. So I can protect that any outbound access cannot reach the preference pod or the recommendation pod. And the last thing before we demo all these things that I explained you here is that GWT or JSON Web Tokens. When we are making requests from service A to service B, from customers to preference, it's important not only to encrypt the traffic, but authenticate and authorize the traffic. We want to be sure that the user has a valid token and that token has the correct routes to access that service. And this is exactly what you can do with Istio. So again, it has been a really quick introduction because we've got only 30 minutes. Here is the exercises, and I'm going to start demoing everything. I've got here my my OpenShift cluster, and in this case, I've deployed this application, which is customer preference, and then we've got recommendation V1, V2, and V3. We've got 3 recommendations, and the first thing that I'm going to do, if you are into Istio, you know that you need to register your services. In this case, I'm going to register recommendation V1, V2, V3. Now I've got these services registered inside the Istio mesh. I know that destination rule can be used for more things, but for now, keep in mind that I'm just registering the services, and then I'm going to apply the following virtual service that is sending all the traffic to V3. It's here, and now I'm just calling customer preference recommendation V3. What's happening if I do a call? You see that I'm just calling customer, then preference, then preference, and then recommendation V3. And notice here the time. This time is not coming from the pod, it's coming from here, wall clock API. Okay, this wall clock API is an external service that gives us a JSON with the current time. So this is what I'm doing here. Service recommendation V3 is doing a request to wall clock API. So by default, Istio allows you to this outbound traffic, but I recommend you that you configure Istio for not accepting this. And to do it, you just need to update the config map of Istio and change the allow any policy to registry only policy. So what I'm saying here is, please Istio, only allow outbound traffic to external third parties, those hosts that are registered. So what's happening if I do now a call? Well, it takes a bit of time, okay, to register. We need to wait now a few seconds, but it's going to wait. Now, you see that now there is an error, okay? It's an error because Istio protects us to do an external call. Then, how we can register that wall clock API is a trusted party? Well, this is done by applying the next service entry egress wall clock API that I'm applying right now. I'm going to show you in a few moments. Okay, you can see here that just registering. Let me do with a cat. It's going to be. Oops. Okay, great. Now, okay, see that it's a service entry, and I'm saying that the host wall clock API at port 80 with protocol HTTP is a trusted. Host. Now, if I do a call, you see that it works because wall clock API is a trusted site. What happens if now I do a delete of service entry egress? I'm deleting this egress rule, so when I do a call, it fails. Okay, this is one thing that you can use to protect your traffic. Now, let me do get deployment. I'm going to remove this deployment. This one. And I'm going to delete the Istio files virtual service recommendation v3 because now there is no v3. And if I do a get pod, you see that now I've got customer preference recommendation v1, v2, and if I do a call, I'm getting v1. Why you always v1? It's happened. Wait a second. It doesn't, I mean, in fact, it doesn't matter. But let me remove everything. Come on. Oh, kubectl get virtual service. Okay, yeah, in theory, it doesn't matter if it's not switching. I don't know why it's not switching to v2 now. Okay, well, it doesn't matter. I mean, it's for what I want to show you, it doesn't matter. Okay, now let's register again. Istio files, destination rule, v1, oops, v1, v2. Okay, now, let me apply the next YAML file. Yeah, everything is a YAML file, right? You love it or you hate it, but it's a YAML at the end. And now what's happening if I do a curl? Oops. Oh. All right. It says access denied. Why? Because notice that what I've done here, we can do a cat, is saying that I want to deny any access between internal services. So it's like, okay, just do not allow any access. Of course, this is not usable, and I'm going to apply another file, which is the authorization policy allow customer. So I'm just saying I allow the communication with customer. So now if I do a call, notice that it says customer because I'm reaching the customer service, but now it says, oh, customer cannot access preference. So I get it an airbag problem, an airbag exception. Notice that if I do a cat of this, you see that I'm saying that a customer, it's allowed to access in the method get, but only the customer. Now, what I need to do is apply another file which says the next thing. I only allow traffic from customer to preference. So again, this is another. And if I do a call, you'll see that now I'm getting customer preference and then the error. If I do a cat like this, you see that now I'm saying that preference is only reachable if the one who's doing the request is customer. And of course, I can do the same thing with preference with recommendation. Recommendation. Okay. Now I'm just saying the traffic that it's not forbidden is the one that is from customer to preference and from preference to recommendation. Now, if I do a call here, you see that it works again. And so you can see that what I'm saying you it's true. Notice that if I do keycatal exec minus ti customer minus c customer /bin/bash, so I'm just entering inside the customer pod, and I do a call localhost 8080, it works. But if I do a call and instead of preference I said I want to access to recommendation 8080, it returns the access denied. So even though I am inside my mesh, I cannot make anything that it's not I'm not authorized to do. So if I'm not authorized to do a call from customer to recommendation, then forbidden. And that's why I said that it's really important to do this kind of things with Istio. And okay, now we can delete or we can clean all the scripts so we get it again the previous version where everyone can make requests to anyone. Okay, it's now I can do curl again. It's still working. And if I do keycatal exec of customer, notice that now I can do curl recommendation 8080, and now it works. Okay, because I've removed all the access control. Another thing that I want to show you, and now I don't want to spend a lot of time because it's something that it's done automatically, is that Istio by default encrypts the traffic between internal services, which means that we as a developer, we are just using HTTP. But internally, Istio transforms the HTTP to HTTPS and sends the traffic using MTLS. And the good things for you is that you do not need to take care of managing certificates of authorities, renewing certificates, renewing keys, nothing. Everything is managed automatically by Istio. Then, for example, if you want to know if MTLS is enabled on your Istio installation, you just need to use istio-ctl experiment auth and check, in this case, the customer service, and you see here that, well, yeah, it's a really big thing, but notice that here it says MTLS and it says yes. So this means that all the traffic is encrypted. Then, if you want, you can use something like sniff, okay, that will allows you to sniff traffic between pods and validate that they are encrypted. But since we are running out of time, I prefer to show you more things. Well, also notice that if you want, you can just disable MTLS. Now I'm disabling MTLS. So now it says, okay, now I do not want to MTLS to any communication. And if I run again this experimental call. See that now the customer is never MTLS, it's never encrypted. All the traffic is not encrypted, okay, between customer and the other parties, okay? So again, it's a really important thing that you need to check all the time, that the internal communication between your services are encrypted, and notice that thanks of Istio, this just happens. Let's see, the last thing I want to show you is authentication and authorization. Okay, what's happened if, yeah?
Just a second, if you can type your commands in the top of the screen, because in the bottom we can't see that.
Oh, wait, I think that I can do this, right? Now it's better.
Yeah, much better.
Okay. Yeah, well, the Istio is this one. Remember that all the commands, everything is on the tutorial that I share with you, so you can reproduce it. But again, what I was saying, that it's really important to have MTLS enabled all the time. Now, let me move to another example, and I'm going to enable, first of all, the end user authentication job. This file, and I'm going to share with you now, it's just saying, I'm just applying and saying that when I want to access the namespace tutorial, needs to be done with a valid JSON Web Token. And the issuer must be this one, and this is the key, the public key to validate the token. Then, what I mean with this is that by default, when I'm just sending a token, if the token has been expired, Istio will validate it and remove that and abort the request. If the token has not the correct issuer, it's going to abort the request. If the token has been compromised and it has been modified and does not validate the signature, the request will be aborted. And all these things happens automatically. Now, what's happening if I do this? I'm just going to copy this, here I'm just doing the call, but wait a second, I'm going to change the URL because I do not have this environment variable to, let me find it here, the curl, it's curl, hello, and here, this is the URL, okay. Now I'm just sending a token, and wait, yeah, it might be that this token is the invalid one. Let me. Okay, now I just getting the token. Oh, wait a second, because sometimes this, if you're okay. So if the token is valid, now I'm just setting this token, then you get it access. But if the token is invalid, and I'm just going to change the token to another token, this one. Now it says GD2 is not in the form from a header payload signature. It will say, okay, I mean that you're providing an invalid token. I can even, for example, provide this. And it will say that the header is invalid base 64 URL and so on. So all these protection are not done in the server side. They are done in in the business logic. It's done by Istio. So your code just have business logic, and all these checks happens on the Istio side. Okay, and this is all the things that I wanted to show. Again, there is much more thing to that you can check about Istio in our tutorial. You will find it. And since we still have one minute, I'm going to just go to this here. Okay, this is the tutorial. Here you've got the HTML version, and here you see security. and you will be able to reproduce the egress example, the access control example, MTLS. One of the great things about the MTLS section is that you will learn how to use ksniff to sniff traffic between pods. Then there is the end user authentication. So this is the example that we've seen now, how to authenticate between tokens. And finally, this is something that we've got no time, but remember that it's not only about authentication, but with Istio, you can also provide authorization protection. And that's all. Have you found it, this talk useful?
Awesome, Alex. Thank you for the talk. And we do have questions. So let me show the first here. So Bram is asking, is it possible to limit traffic and apply RBAC on the egress traffic, maybe using a service entry?
I'm talking in memory, and I think limited traffic is something that I think that they was implemented to deprecate from newer versions of Istio. I think that all these policies were they were not pretty sure if added or not, but RBAC, yeah, I think that you can apply it to the egress traffic. Yeah, because you can create a bureau service and then apply it.
And Jorge is asking, does MTLS increase the latency between internal communication in microservices?
Yes, because you're encrypting and decrypting the traffic, but I'm sure that the latency is pretty small. And just keep in mind that if any of these services are compromised, any attacker could sniff any traffic between any service. So it's a good practice to encrypt all the internal services. But of course, you are paying some minimal latency because you're encrypting and decrypting things.
And another one from Peter. What about layer 3-4 communication? Can you control layer 3-4 communication with Istio, like TCP, UDP, ICMP?
You can control TCP, not in the same range as HTTP, but you can control some things. And UDP, I guess that too, but ICMP not. And with MP, I'm not 100% sure. I guess that you can, but I'm not 100% sure.
And is it easy to enable on OpenShift?
Yes, in fact, I can. I mean, if you're in, I can even show you. Wait a second, because I mean, I've got. I mean, all this demo is in OpenShift, and let me find my OpenShift installation. It's here. Okay. Oops. Sorry. Move. Now. Here is no. What is now? Oops, now. Okay. You just need to do two things. Just you need to go to operators, operator hub, and just find for Elasticsearch operator and put it here and push install. That's all. Then you need to find for if you want to use Jigger, then you can install Jigger. If you don't want to use Jigger, then don't install it. And then we've got the service mesh operator. You just put it in install, and then it will appear here. You see that we've got, because I also have Kayali and all this stuff, but at the end it's install what you need. And then in the service mesh, you need to go to the service mesh control plane, create service mesh control plane, and then you've got Istio installed. So let's say that you only need to install the Red Hat Open Service Mesh operator, go to the Istio service mesh control plane, push this button, accept the defaults. Of course, you can change it if you will, and everything is installed.
Awesome. Well, we are already on top of the hour. So I'd like to thank Alex for presenting this awesome session about Istio and security. I'd like to thank you for watching us here on DevNation, and stay tuned. We have a lot of content, and we always have another This Show or Tech Talk for you every single Thursday.
Thank you.
Okay, bye.
Bye.